Okay. So I'm going to share my screen. Alrighty, so welcome to VEXCode Virtual Robot, or I just call it VR because it's short. Session 1. My name is Kai Lee. I'll be your instructor for today. There's also Mr. David, who's going to be the co-host of this meeting. All right, so first thing first, what is VEXCode VR? Some of you guys signed up for this class. You might already know what VEXCode VR is already, but I'm going to repeat it. So VEXCode VR, it lets you code a virtual robot using block-based coding environment. So block means you just click and drag, everything is already there. You don't really have to code it yourself. So basically you don't really have to type in anything. All the functions are already there. We will go over the functions in just a minute. So this is the same programming environment used for VEX 123, VEX Go, VEX IQ, and even V5 robots. That should be V5, by the way, not V4. It should. So if you guys already did VEX IQ or you guys use block coding for your VEX V5, this should be very comfortable to use, very simple. It was developed specifically for distant learning. So as soon as the news about coronavirus came out and all the breakouts and stuff like that, and you know, we started getting locked inside our house, VEX upload this thing. VEX VR is completely new. So it's on the website, so vr.vex.com. So everything is going to be on website based. You don't have to download anything. Very simple. You don't even have to download it to run it. You can just run it completely on Google Chrome or Microsoft Edge or whatever you want to use. So do me a favor and turn on your Google Chrome and type in vr.vex.com. So I'm going to do it right now. I have the hyperlink here already. So I'm just going to click on it. All right. So let's move on to our robot. So one benefit of VEX VR is that the robot is already pre-configured for you. You don't have to build anything. You don't have to assign motor ports and stuff like that. Normally, when you build a robot, there are a couple things you have to connect, like say the wheels, you know, like normally you have two motors for the wheels, the left motor and the right motor. You have to connect, say, port 1 and 2. So you have to go to your VEXCode or whatever programming language you want to use and basically tell the programming language that, okay, the motor on port number 1 is going to be for the drivetrain. The motor on port 5, for example, is going to be for the lift, stuff like that. So for each thing you want to connect to your robot, there's a specific port that you have to tell your computer in order to code it. One advantage of VEX VR is that you don't have to configure it. Everything is already configured for you on the web base. But one disadvantage is you're basically stuck with this robot. Say you want to build something else, you want to add another motor, you want to add another wheel, you want to add an arm or whatnot, you want to add another sensor. You don't have the ability to do that. The only thing you can do in this is to code that robot on the screen right now. So let's talk about the robot real fast. So it has 4 wheels, 50 millimeter diameter wheels. Don't have to worry about that. That math is not really important as of right now, so I'm not going to go over it. The pen, you can use the pen for, let's see, the chat. So the pen is useful. So normally when you build a VEX robot, you don't really need a pen, right? Like who put a pen on their robot? So the pen in this robot is very important because it actually draw out the path of your robot for you, and you can analyze that path. Say if I want to go straight, turn left, turn right, it's going to draw that path onto the field itself. I will show you in just a second. There's also an electromagnet. I know it sounds horrible, you know, electromagnet, who use that on the robot. Sounds very complicated, but basically the electromagnet in this case is just acting as a grabbing mechanism. So instead of building a motor with an arm that you have to grab an object, say, normally I have this can right here. If I was a robot, I want to grab it. I have to have an arm and grab it, move it, stuff like that. So VEX made it very simple for us. We don't have to use an arm, so there's no motors. Everything is interactive via that electromagnet. We're not going to go over the electromagnet today, but we will in later sessions. There's also a down eye for tracking colors, tracking how far you went, stuff like that. On this side, there's a bumper sensor, 2 bumper sensors in the front. So the right bumper sensor and the left bumper sensors. There's also a distance sensor in the front. They call it the front eye. It's also have a webcam incorporated inside it for color sensing, distance sensing, stuff like that. And also the gyro and location sensing. So what we're focusing on today is this thing, the gyro and location sensing. All right, so let's go to VEX VR real fast. Let's talk about the interface of VEX VR. When you go to vr.vex.com, this is what you should see on your computer, on your browser, right? So let's talk about the interface real fast. This is what you're gonna see. There's a lot of buttons on the left side of the screen. There's a lot of buttons on the top side of the screen, stuff like that. We're gonna go over the stuff that we're gonna use today. So let's talk about the left side, the left menu. These buttons are for different functions of the robot. We have a drivetrain function. We have a magnet function for the electromagnet. We have a looks function. We have a look functions for camera sensors, control, sensing, operations, variables, my block, and comments. We're not going to be focusing on much of them today. The only thing we're going to focus on is the drivetrain and the sensing. That's it. And on this side, in the middle, there's this top side menu. Let me move this. There's this top side menu. So this top side menu is very important. There's different functions about it. On this globe right here, if you click on it, you can change the language. So if you don't speak if you don't speak English, you can change to a different language, like, I don't know, whatever you want to. I think have like French, Spanish, and stuff like that. You can save your file. So after you code it, you can save it as whatever you want. And then the next time you go in it, you can also import your file, rename your file, stuff like that. The tutorial and activities, we're not going to touch those at all. It's more like examples of what you can do and what activities VEX suggests you should do. In the middle, right over here, we have the name of your project. So you can actually rename it when you download your projects. Over here, we have these buttons. These buttons, in my opinion, are the more important one. So the playground is the place where your robot runs. So you're gonna code inside VEXCode, and you're gonna press on playground or start, and it's gonna start your robot, and you can see it in real time. And if you click on step, it's actually gonna do it step by step, so you can follow what you just coded. The stop buttons, pretty self-explanatory. Stop your robot, stop the entire program. The share and feedback. The feedback button is more like, hey, I encounter a bug in the program. I want to send that bug to VEX so they can fix it, whatnot. We're not going to worry about that. Same thing with the share button. If you want to share your program with your friends or whatnot, you're more than welcome to do that. But we're not gonna go over that today. By the way, if I'm going too fast, please tell Mr. Button or tell me just to start talking to me. I'm gonna slow down for a little bit if I'm going too fast. All right, so let's talk about the functions that we're actually gonna use today. So if you look at this slide, there's different colors on the left side. We're only gonna focus on 2 colors, that and that. So the drivetrain and the looks. Let's talk about the looks first, because I feel like this is more simple. We don't care about the looks functions. I'm only going to use the look functions today for the pen. That's it. And the pen is to analyze your robot path. That's all I'm going to use to look for. So the only function we're going to use inside looks is the move robot pen down. That's it. If you want to change the color, you can set the robot pane to color whatever color you want. I'm just going to leave it in black as the default because I don't think color matter that much. Let's start talking about the drivetrain. This is the more important one. So you have a couple functions over here. The drive forward for how many millimeter or centimeter or meter that you want. You can also turn, of course, you can turn left, turn right. For how many degree do you want to turn? You can also use the turn to heading 90 degree. This is gonna take a little more explaining to use that functions. We are not going to use that function today. There's also a function to stop your driving, to set the drive velocities. So it doesn't matter that much in VEXCode VR because it's a simulation. It's not the real thing. There's a lot of variables you don't have to deal with. Say if you build a robot in real life and you want to take it to competitions, there's a lot of variables you have to deal with. There's drag. There's like how slippery the mat is. You might lose tractions and stuff like that. There's just a lot of variables to deal with. And one way to combat those is to set the drive velocities slower. So if you drive really fast and you want to turn at exactly 90 degree, sometimes your robot drive a little too fast. It's going to overshoot that and it's going to turn for like say 95 to 100 degree. So you're not going to be as accurate. A good thing about VEX VR is your robot is very precise. It's a simulation. There's no variables you have to deal with. All you have to deal with is your robot and the field itself. So we're not going to use the drive velocity today for that reason. If you want to slow your robot down, you are more than welcome to do that. I don't know why you would do that, but you're more than welcome to. Same thing with turn velocities. If you're going too fast, the turn might be a little bit weird. Same thing with drive heading. Again, we already talked about the turn to heading up there. We're not going to worry about that today. All right. So let's talk about the difference between the drive forward and drive forward for how long or for how far you want to go. If you don't have a gyro sensor, which in VEX VR is already built in, but if you don't have it, then the only option you would have is to drive forward. The gyro sensor is responsible for calculating how far your robot is from a set point. So what a gyro sensor does is at the very beginning, when you start up your program, it will register that point as 0, 0. And say if you go forward for 200 meters, your gyro sensor is going to change. If you go forward, it's probably going to be in the Y directions. So then now your robot, after going forward for 0 to 200 degree, your coordinates is going to turn into 0 / 200. It's complicated, I know, but when you go into practice, you understand it way easier. So we're not going to use the drive forward function at all. We're going to use the drive forward for how many millimeters we want, because of course that is way more precise. If you have the option to go forward for how long you want and how far you want, it is way better to do that compared to moving forward for how many seconds. All right. All right, so I talk about coordinates. So this is your playing field, the map that you pick. So there are a lot of options for maps that you're gonna pick, but today we're only going to focus on one map. But the basic of VEX VR is each map you select have a 900 times 900 millimeter playing field. What does that mean? That means the sides are 900 millimeters each. So it's a square, 900 millimeter each. It is calculated by an X and Y coordinates. So X coordinates is left to right, and Y coordinates is up and down, right? If you take, geography, or if you're in very low level algebra, you probably learned about graph and stuff like that already. But Y coordinates up and down, X coordinates left and right. The reference point, 0.0, is on the top right side. So this is 0, 0. So if you're in the bottom left corner, you should be at negative 900 and negative 900. Say if you're in the top right, oh yeah, top right is 0, 0, sorry. If you're in top left, then Y coordinates should be 0, and X coordinates should be negative 900. So this is negative 900 slash 0. All right, so let's go over this real fast. This is the interface that will show on your screen when you turn on the activity for your VEX robot. Let's explain a couple of things that we're going to worry about. So obviously, we're going to worry about the play button, right? So whatever you code, whenever you press play, it's going to play over here. Your robot's right here. It's going to start moving across the map and stuff like that. The reset button, say you change something in your code and you want to run it again, first you have to press reset and then press play. You can also change camera angles to top down or side view, stuff like that. Really doesn't matter for us as of right now. One more very important thing is the location, the angle, and the distance. So whenever you start, this is 0 degree, always. It looks like it's 90, but it's not. It should be 90, but they code it as 0 degree. So this is 0 degree. So your heading right now is 0 degree. If you start right over here and your robot is looking that way. The distance is the distance between your robot at the front and the nearest wall. So right now, let's say 292. That means your robot from this point to that point is 292 millimeters away. And your location for your robot. This is the X and Y coordinates for your robot. We're not going to go over that. It doesn't really matter to us that much, the locations. The most important thing you have to worry about right now is the distance. So this is basically the values that your sensors is giving you in real time. So wherever your robot go, those angles is going to change. And I will show you in just a minute. So let's switch over to VEX VR and test something out. You guys are more than welcome to switch over as well to VEX VR. I'm going to switch my screen. Yes, so if you want to go very accurate, you can have your robot head forward for how many millimeters you want, correct, Tarek? So let's test a couple things out. So this is what you should see when you turn VEX VR on. So vr.vex.com, this is what you see. There's nothing on it except for this button right here, when started. So first thing first, I want you to change the playground. So as of right now, it's going to be in grid map. We don't worry about grid map right now. We're only going to worry about wall maze. So click on wall maze. It's going to load and you're going to see this screen. So there's a couple of points, A, B, C, D, and 1, 2, 3, 4. And there's also a final point that your robot need to hit, whatever. We're not going to worry about that yet. Let's test something out. Let's say I want to move forward for 200 meters. right? So I'm just gonna click that and drag it over. That's all I gotta do. Make sure these two buttons are connected. These two blocks are connected. That's all I have to worry about. So I'm gonna drive forward for 200 millimeters. What I'm gonna do after I coded that is I'm going to press play and my robot should move forward. So as of right now, my robot is 292 millimeters away from the wall. If I go forward for 200 millimeters, this should show me that my distance is 92 millimeters away from the wall when I finish. Let's see if that's true. Press start, move forward. Now I'm 92 millimeters away from the wall. So that's the moving forward function, right? Let's change the camera angle so you can see it. So if you were a person and you code your robot, this is the view that you would see. Press start, robot move forward for exactly 200 millimeters. Again, a very good thing about VEX VR is everything is precise up to the dot. You don't have to worry about any weird variations or, any weird condition that your robot might be at. This is perfect condition textbook, okay? So after I did that, I'm going to press restart if I want to bring my robot from this point to that point. All right. So let's test out a couple things. Say I want to analyze my robot's path. So how do I do a path? You go to looks, click on looks. There's a button for move robot pen down. Click it, drag it right in the middle. So first thing you should do is to move your robot pen down. VEXCode is very easy to analyze for the fact that your robot always starts from the top function to the bottom function. So if I have it like this, it's going to move the robot pen down first, and then it's going to move forward. But if I switch it around like this, now my robot is going to move forward, and then is going to put the pen down. So let's test out each scenario, okay? I'm gonna put the robot pen down first and then drive forward. Let's reset it and start. Now you can see there's a black line right on my robot, right behind my robot. That's the trail that the pen just made, right? By dragging that pen across the floor. That's the trail my robot just made. All right, let's start it again. But this time, we're going to switch these around. So now instead of putting my pen down first, I drive forward first, and then I put the pen down. We'll test it out. This time, if you look at it, there is no pen trail because it stopped and then put the pen down, which means the pen hasn't really, put into place yet. Does that make sense? If that makes sense, can you put a thumbs up in the Zoom meeting so I can know that you guys understand what I'm saying? There you go. See some thumbs up. That's good. Perfect. Perfect. Thumbs up. Perfect. All right. So again, everybody go back here. We're not going to use grid map. We're going to use wall maze. So just remember you're on wall maze. I cannot monitor your screen, so you gotta do it yourself. All right, let's go back to the PowerPoint. All right, so this is the programming to get to A. You can see the programming. You can take a picture of it as of right now, so you can copy it down. But I highly suggest just kind of code it yourself and go over it step by step with me. It's a lot easier doing that. So let's see. The code look like Scratch code. Yes. It's actually Scratch based. It is based on Scratch. All right, so I'm gonna put this right here. All right. So this is your starting point. You want to get to A. So let's analyze how we're gonna do that, right? Same thing with VEX competition. Say you go to competitions, you want to get to that point. You have different tasks that you're gonna have to do, but you can't just do it, right? You got to analyze about it. If you were driving it, it would make it a lot more natural. You know, you can just go forward and stuff like that. But if you're gonna do autonomous, you have to step it down step by step. You have to analyze every single step. What am I gonna do next? What am I gonna do now? What step am I taking? Stuff like that. I highly doubt that you can use Scratch to program your VexIQ. I might be wrong. I think VexIQ as of right now only support whatever Vex is pushing out. So VEXCode and VEXCode text-based and block-based. That's just what I think. I'm not sure. I think you can also use Robot C, but I don't think you can use Scratch for VEX robots. All right. So let's analyze how we're going to get to A, right? The robot's right here. So we're going to move forward, right? And we're going to stop. We go into turn left. And we're going to move forward, stop, turn left again, and move forward, right? Okay, simple enough. So let's do that. So you guys are more than welcome to do this with me, by the way. You don't have to look at me doing it and then do it later. So I have my first function, drive, move forward for 200 millimeters. Okay, cool. And then I'm going to pull this out and say I'm going to turn left for 90 degrees, and I'm going to move forward again. All right, that's our first step. First step ever. Let's test it out, see what happens. So I'm going to move forward for 200 millimeters, turn left for 90 degrees, and then I'm going to move forward again. All right, let's press play. Now we're going to look at our robot. So if you look at your robot, it's a little too close to this wall, right? So it's not going to be straight. If it scraped that wall, then your path is not going to be straight. So instead of 200 millimeters, what if I go forward a little more, right? So I just coded that, press reset, and then press play. So now my robot should go forward a little more, and I was able to clear that wall, correct? Notice how the robot was here, and now it's like up there. Yep. Okay, great. So now I got to that point. What do I want to do next? Do I want to turn left and go forward again to reach A? Yep, that's exactly what I'm going to do next. So point this out again, turn left for 90 degrees, and go forward for, we don't know how far yet, so I'm just gonna put in 200 millimeters. Okay, reset, press play, let's see what happened. So this time, if you look at it, the line was a little bit weird right over here. And the reason was because we hit that wall, right? So there's a wall right there. We didn't, consider there was a wall right there. So now we got to fix it, right? It was a little too close. So what do? We just widen it out a little bit, okay? So we went a little too tight. The turn was a little too tight, and we hit the wall, and the robot was struggling a little bit right here, right? And that is why the pen is very crucial, because it allows us to analyze our robot's path. You can't really do it in real life. If you want to put a pen down and then draw on your field, you're more than welcome to do that, but you can't really do it in real life. That's one of the advantage of XVR. You can see it in the simulations. There's no damage done for your robot or your field. So let's clear that by bumping this up another 50. All right, let's see what happened. Let's see what happened now that we bump it up another 50. Press play. Should be able to clear that wall. All right. All right, great. So now we see that. But we're not really inside the A, you know, there's a little space up there that we can wiggle our robot in, so it's actually hitting A, right? So how do we do that? We bumped it up again, you know, try and error, right? You just do it over and over again to get it right. And press play and turn, and another turn right there. So now we completely cleared A, right? So that's the good thing about VEX VR. Try and error. Same thing with robotics. You know, you can't really get everything done right the first time. If you can, great. You know, good job. You're a genius. But more than often, you're not going to get it right the first time. And that's okay. Just go back to your code and just recode it or modify it or whatnot. And then you're going to have this code. I'm pretty sure I put this exact code into the PowerPoint. So if you need any help later on or you don't understand how to do it, you're more than welcome to go back to the PowerPoint and do that. Yep, that is the exact same code. Let me share my PowerPoint with you. And there you go. Oh. So now that we went over the foundation of how to make your robot move and how long, how far, stuff like that, now we're going to go to the challenge. I have a couple of challenges that I've prepared for you guys here. This is the code that I just did, get to A, the exact same code that I just did for you guys to see. So now we're gonna go to a couple challenges. So I have 3 challenges right over here. I instead of naming it, I just kind of put a picture on next to it. The bear challenge, the wolf challenge, and the reverse challenge. So if you look at it, if you look at the wall maze, there's a couple points with letters and numbers on it, right? So your task is to hit every single point and then go to the final directions, final destination. So there's point A, B, C. So the bear challenge is for you to hit point A, point B, C, and D. The wolf challenge is for you to hit number 1, number 2, 3, and 4. And then the reverse challenge is instead of doing alphabetically, you're going to do D, C, B, A, and 4, 3, 2, 1 instead. So let's go back to VEX VR and try to see if we can hit point B. Let me switch it to VEXCode VR. There you go. Okay, great. All right. So I hit point A. My robot's right there. But now I have a problem. My robot is facing a wall, right? So do I want to go backwards or do I want to turn 180 degree, right? I have that problem. So now I'm kind of stuck there. I can't really just go forward anymore. So let's do that. So now there's 2 options, right? If you look at your heading, it's at 180 degree. I can do turn to heading at 0 degree, and that could work. But just to make things a little more simple, I'm just gonna turn right or left. It doesn't really matter because I'm staying at one spot, right? So it doesn't really matter. I'm gonna turn left for 180, right? Let's see what happens. Now my robot should just go there. So turn, go straight, turn, go straight, and it's gonna move 180. Completely facing forward again. So cool. So that works, right? Now I want to get to B. From there to B. Let's see. So I'm gonna move forward, turn left, forward, left, forward, right, forward, right, forward. Cool. So let's do it step by step. So as of right now, I don't know how far I have to go, right? But it looks to be about, I would say double. So instead of 250, I'm just gonna move forward for 500, right? See what happens. So turn, stop, reverse, forward. Okay, so 500 works just fine. So now I get to that point. Now the next step is to turn left and move forward. So let's do that. I'm going to turn left for 90 degrees and I'm going to move forward. I don't know how far, so I'm just going to leave it as 200, right? Again, try and error. You have no idea how far your robot's going to go. That's fine. Just estimate it, change it later. Hit A, go forward, turn, forward again. So if you look at the scenario, my robot is right next to this wall. If I turn and go forward, it might hit that wall, right? Just like I hit this wall early on, it might hit that wall. So with the robot and my best interest, I would like to move forward a little more just to clear off this path, right? We have a ton of space right here. So why don't we move forward just a tad more, okay? So let's reset that. So I have 250, 200, I'm gonna do 250. And now that I have that 250, I'm gonna go forward, I'm gonna turn left again. Turn left, 90. And then I'm gonna move forward. All right, so now that we have that move forward 500 millimeters, that it works. So let's do that. Let's just copy paste, because this path right over here is the same with this path over here, correct? It's the same exact distance. So let's do 500. All right, reset, play. Let's see how that turns out. Oh, you also see the green, it flashes your code over here. That means that's the step the robot is at. It also analyzes every single step you have. All right, cool. I'm at this point now. Now I'm gonna power it through. Turn right, go straight, turn right, go straight, okay? So let's do that. So turn right, go straight, or go forward, sorry. 500. It looks like about the same distance, right? So 500, that works. And then turn right again. And then drive forward. So if 500 gets me from there up there, and I do 500 again, it will only get me from there to there. I might want to go forward just a little more. Now, I don't know how far. So let's just do 700 and see what happens, all right? If 700 is a little too short, we're gonna add like 50 into it. If it's a little too long, we're gonna minus 50 to 100. We don't know yet, so we're gonna test it out. Just go forward and turn, forward, turn, forward, turn. There you go. Let's see if we can make it to B or not. And perfect, we made it to B. Yep. Not quite fully, but that's okay. All right, so that's pretty much it for B. Just repeat the step, and you're gonna get to C, and then D, and then you're gonna get out and move all the way over there, right? Again, I don't have enough time to go over the entire maze with you, so I'm just gonna do it as far as I can. But the challenges are pretty clear. The bear challenge that I have is A, B, C, D, and the wolf challenge is 1, 2, 3, 4. And then if you want to do it in reverse or whatnot, you're more than welcome to. Or you don't even have to hit those points. You can just, navigate through the maze and then just hit the final button, the final spot, right? So yeah. All right, let's go back to the slide. Let's see, share screen, PowerPoint, shared. You guys see my PowerPoint right now? There you go, PowerPoint share. All right, so that's the couple of challenges that I have for you. A, B, C, D, 1, 2, 3, 4, stuff like that. You're pretty clear on the challenges. That's pretty much it for today. That's all I have for you guys today. Does anybody have any questions that they want to ask, or if there's anything that you want me to do it again so you can see it? If there's any questions about an interface, stuff like that, I'm more than happy to answer. Again, this is our first class ever in the series of classes that we're going to have for VEXCode VR. So I designed this to be very foundational. So if anyone already have knowledge in this, anyone already know how to do VEXCode, great. We're going to do a lot of hard stuff, like, a lot more hard stuff later on. We're going to do a lot more challenges later on that you're going to actually, feel like it's tough. I get that today is very easy, but then again, it's foundational. It's for people who never used VEXCode VR before, to go over the interface, to go over how the robot works, to go over how block coding works, stuff like that. All right, does the VEX VR robot sensors exist in real life? Yes. The distance sensor exists in real life. The gyro sensor definitely exists in real life. All that sensors does exist in real life, except for the electromagnet one. I'm not sure if VEX VR has it. I mean, VEX IQ has it. The last time I checked, it didn't, but they might do some crazy stuff. They just came out with a new update, so who knows, right? But as of right now, no. Electromagnet does not exist. Color sensor does. Gyro sensor does. Bumper sensor does. The motors definitely does. But yeah. Any other questions that you have? Will I send you the recording of this? Yes, I will. I'm going to upload the recording on YouTube, and I will send you the link to it. And I will also email you the PowerPoint for today's sessions. Is there any other questions that you guys have? I mean, I allow 15 minutes for questions. The next class is going to be on, if I'm not mistaken, Wednesday the 29th, the 1st. Let me see. Carlos, do you have any questions?
Excuse me?
Do you have any questions?
No, I'm doing pretty well.
Okay, if you don't, do you mind muting yourself so it doesn't get noisy? Yes, the link to the next meeting is I'm going to email you just like today, uh, another link for the next meeting. Let's see. So the next sessions for this is going to be the 29th and May 1st. Yep, so Wednesday and Friday, correct. So after this class, again, I'm going to upload this video on YouTube. I'm also going to email you guys the PowerPoint slide. Any questions related to VEX Robotics or the class or the time and stuff like that?
I just looked, there are some other programming languages for different VEX controllers that are more like Python. I think the RoboMesh platform is Python, or they have a block one. It depends on what controller you're looking to use too.
I do not work with VEX. So I did VEX competitions pretty much since middle school. So back in middle school, I joined a VEX team. I joined a VEX team in high school. I'm now in college. Unfortunately, I'm not doing VEX anymore, but I'm coaching VEX. So I've been working with VEX for a while now, working on VEX robots for a while now, probably since 2015, 2014, 2015. So yeah, I've been doing it for a while. Yes, you can have different projects in VR, Michael. So there are different projects in VR. I'm going to show you right now. Obviously, we're not going over it, like the whole thing, but I'm going to show you some of the project that you can do. Let's see. So VEXCode VR. There you go. All right. So VEXCode VR. So that's just the first challenge, right? Yeah, there are different projects that you can use. I mean, there's all these maps that you can do. There's there's a grid map that is just grid, obviously, just dash and dash. There's also a number grid map, which has number 1 to, I think, 900, if I'm not mistaken, to 100. There you go. So from 1 to 100. There's also art canvas, so you can use the pen functions to draw whatever you want. There's a lot of options for you. And in this class, we're going to go over a couple of other options as well. We're going to all go over the castle, and we're going to go over the maze with the number grid map. So those are the two activities that we're going to do in this class for Wednesday and Friday. There's no best playground to program on. It depends on what kind of skill you want to test. You know, if you only gonna use the pen functions and trying to draw something really cool, obviously use the canvas one, right? What is the best platform to program on for competitions, right? Let's see. So for competitions, there are limitations. So for VEX VR is a platform developed for you to use your robot to simulate a competitions scenario. VEX VR is a learning tool. It's for educational uses, for you to learn how to use VEX code. You can't really use VEX VR to say test out the next VEX game, because there are a couple limitations you have. Again, you can't really build your robot, right? You can't import your robot. You can't fix a part that you don't have. the robot is already preset. You can't really do that. And as of right now, I don't think VEX have any interest in importing new maps into it, so new playgrounds and stuff like that. They're definitely not going to import the next VEX IQ or VEX VRC game into this because the dimension is not correct. If you remember in the presentation, the dimension is 900 times 900, which is definitely not the dimension of the real, competition field. So I go to college at George Mason University. I'm majoring in computer engineering. Any other questions that you might have? All right, so we have 10 more minutes. So I'm just gonna use this minute to try to code the robot to get to C, right? We have an extra 10 minutes. You guys don't seem to have any questions regarding VEX that much. It seems that everybody understand what to do, how to do it, and stuff like that. So let's go to C. Let's go to C. All right. So starting the playground again. Wall maze. Yada yada. All right, let's run it one more time. See how far we got, because I kind of forget. All right, so we hit A. We do that. We turn and we hit B. Cool. All right, let's try to hit C. All right, C is all the way over there. By the way, about this coding that I just made right there, this is not the most effective way to do coding. We're actually gonna go over how to use these control over here and how to create your own functions next class. So this class, you're not making your own like variables or your own function or my block or whatnot. You're not doing it this class because, again, very introductory. I want everybody to get their robot moving first. I don't want to overwhelm you guys, but we're not going to do this next time because, when you think about it, just a couple steps. And I already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like more than 12 blocks on my code, which makes it very messy. Say I don't want to solve this entire maze and have like 100 lines into my code. It makes it a lot harder for you to troubleshoot. Say, what step did I mess up at? Right? If you have 100 codes, it's going to be pretty challenging to see like, okay, I messed up at that exact step, right? Or say if you want to solve the entire maze, you have like thousands of lines of code and you mess up one little tiny step, it's going to affect the entire thing, right? So this is very messy. For robotics or for coding in general, actually, one of my suggestions is if you can do that one exact job for either the least amount of time or the least amount of step, that would be better. Oh, Denise have a very good questions. How do you save your program? You go to File and you say Save to your device. This is going to open. I'm just going to save it in desktop right now. So say VEXCode. I'm just going to name it as VEXCode and my name, right? Yeah, I'm just going to save it right there. Save. And say I want to, so now if I turn on my, let's turn on my desktop so you guys can see it. There you go. So now I'm on my desktop, right? And this is what I just saved right here. VEXCode VR block. Excuse me for 1 second. Just muted it. So I have VEXCode VR block right here. That's the program that I just saved. Now, that's how you save it, but how do you import it, right? So let's go back to VEXCode VR. I'm just going to refresh this page because I just saved my programming. Every time you refresh the page, unfortunately, your code goes away. So a good practice to do is to save your program like periodically. Say, save it every half an hour, save it every 15 minutes, whatever you want to do. So you go to File. So let's say you want to import something, right? You go to File, you go to Load from your device. It's going to open that tab. If you're on Mac, I guess it's the same exact way. I'm not sure. I don't have a Mac. You open it and your code just automatically import into it. Does that answer your questions, Denise? Great. Okay. You can also change the name of it right over here. So if I don't want to name it VEXCode Kai, I could say very long code, and then my name. It makes it easier. I rename it, whatever. And then I press save and same exact thing. Okay. Any other questions, or are you guys good for now? Again, our time is pretty limited. I have only 1 hour. I didn't really have enough time to do all the challenges that I present to you. But I highly suggest if you have the time, you can just sit on your computer whenever you're free, maybe before you go to bed or whatnot, or maybe right after this class. Test it out, drive around, try to give a little challenge for yourself. See if you can actually solve that maze by the challenge. So reach point A, B, C, D, and 1, 2, 3, 4, and stuff like that. Just try to challenge yourself and stuff like that. But yeah. All right, guys. That looks like that's it. Thank you so much for joining the class. Again, my name is Kai. I will be your instructor for next class as well. I will email you this slide that I have. I will email you the reference code for the code that I just did. I will also upload this video on YouTube, and I will email you that link as well. Everything will be in one email, and I will send it to every single one who signed up for this class. So yeah, see you guys on Wednesday at 7 o'clock Eastern time on Wednesday. You too. Have a good night as well. Any other questions that I can answer for you guys, or